Substitution reactions that take place at the carbonyl carbon are known as acyl substitution reactions. Just like other substitution reactions, we're replacing one group X that's at the sp2 hybridized carbonyl carbon with another group Y to make the new carbon-Y bond, and X, which will be a leaving group, will be displaced. Since the species Y is typically a nucleophile, these reactions are very commonly referred to as nucleophilic acyl substitution reactions. As we'll learn about in the upcoming webcasts, substitution reactions that take place at the carbonyl carbon, which is sp2 hybridized, are going to go by a mechanism that's much different than the SN1 or the SN2 reactions that we talked about when we talked about substitution at the sp3 carbon atoms. Before we look at the mechanism, let's take a look at some examples of real bonds and atoms, reactions that take place involving acyl substitution. Here are three examples. In the first example, the nucleophile, which in all three cases is going to be colored blue, is displacing at the carbonyl carbon the leaving group, which in all three examples is going to be colored pink. You can see that at the carbonyl carbon, the chloride is displaced with methoxide, charge is balanced, the negative charge is now on the chloride, and we have the new carbon-oxygen bond. You should recognize this as a type of substitution reaction taking place at that sp2 hybridized carbonyl carbon. The second example involves a neutral amine as a nucleophile. It's displacing in pink this acetate group. Charge is balanced because at the end we have the negative charge borne on that acetate group, but notice that there was a positive charge which resulted on the amine picking up a proton. That proton ultimately came from the nucleophile, since the final product only has a single NH. The last example, which is known as esterification, takes this neutral alcohol and replaces the hydroxide. It's usually carried out under acidic conditions where the acid serves as a catalyst. It doesn't get involved in the stoichiometry. You can see that on the left we have two neutral species, and in the product we have two neutral species as well. The proton simply serves as a catalyst, and we'll see the mechanism as to how this acid catalyst gets involved. There you have three examples that we'll study the mechanisms for. They go by very similar, but they have some slight differences in their mechanisms, and that's what we want to learn about in the next webcast.